En los últimos años ha habido grandes avances en el tema que llamamos inteligencia artificial, es decir, en tratar de que las computadoras y el software hagan cada vez más las cosas que hasta ahora solo podíamos hacer las personas. Vamos a hablar con Manuela Veloso. Ella es profesora e investigadora en la Universidad de Carnegie Mellon y trabaja en temas de inteligencia artificial y robótica. En particular, trabaja en un tema llamado robótica autónoma, es decir, en robots que reconocen a través de sensores el contexto en el que están, pueden tomar decisiones sobre lo que deben hacer en ese contexto y además pueden actuar. Okay, so Manuela, thank you very much for being here and for your time. So my first question is about this problem that we have in many countries, that women are underrepresented in computer science, and that's a big problem. So I wanted to ask you how you chose the field of computer science, and why do you think we have this problem?
So I chose the field of computer science because I actually always liked math when I was a kid. So I liked to study math. I liked the rigor of being able to abstract concepts and manipulating these concepts. I liked math. But then when it came to studying in the university, my father said, oh, math, you are going to be just a teacher of math, and so why don't you go to engineering? So I studied engineering just because I liked math, and it was a good application of math. And then when I finished my undergrad degree in Lisbon, I then became interested on this problem of automation. So how do we actually program machines to automate things? So, and in some sense, I started doing research on this area of AI and robotics, starting off from math, with this goal of solving problems that required automation, like a search or some kind of task that could be done by computers. So yeah, I mean, I got some kind of passion for computers and then became more artificial intelligence. But that's the path, my own path. And I don't know exactly why women have more difficulty coming to computer science, but I do believe that people may think that computer science is all about just programming or just hacking, I don't know. But it's a very beautiful field to try to address complex problems, you know. So if you care about things in society that are difficult, rescue situations, all sorts of problems of trying to help people to solve real problems. So computer science is a way. So we are not finding a cure for cancer. That's for sure not what we are doing. But we are enabling a lot of these big questions to be addressed. So especially now that basically everything in society requires you to handle data, be it from your computer, from your cell phone, to, in fact, these experiments in labs, be it music, be it all sorts of disciplines are about data. And data ends up being computer data. Right. And so I think that people should get more interested in computer science also because of this ability that to solve any problem, you really require computers and you really require computer science.
Okay, great. So we hope we can convince more women to get into this fascinating field. So talking about problems of society, your title at Carnegie Mellon is Herbert Simon University Professor. That's right. And Herbert Simon was a Nobel Prize winner in economics, but he was also a sociologist, political scientist, computer scientist, psychologist. So how did such a fascinating person as Simon influence your work?
It's a difficult question to answer. I did know Herb Simon personally for many years, and I have an enormous respect and admiration from him. I learned basically all my vision of computer science was educated by Alan Newell and Herb Simon at Carnegie Mellon University. I don't know. I think that the thing with Herb Simon and my education at Carnegie Mellon for 30 years has been about thinking that these computers can actually be programmed to do more than just computation of numbers, but they can be used to capture symbolic thinking, reasoning about how to solve problems. So these AI and robotics in particular, in which I work, is about being able to specify a problem in terms of the state in which you are. I mean, the robot is in this room, there are this many people, the traffic, there is this amount of traffic. So you kind of like structure your thinking by saying, this is the situation where we are. And then you have some goal, which is like a desired state in which you want to be. So the robot would have to be somewhere in some location in the building. And also, in addition to this initial state and that goal state, you have the actions that are available. You can buy this, you can move left, you can do more, or imagine chess, you can move these pieces. So you structure your problem to be solved as, I'm in this state, I want to get there, and I have all these actions that are possible. And somehow the research, even biased and influenced by Herb Simons and Alan Newell, you try to develop methods to generate a sequence of actions that are able to transform this state in which you are into that final stage in which you would like to be. So now the algorithms, the computers, what they help is to actually come up with this sequence of states. So that's the type of research I do, in the sense that I want to generate the ability for a robot to assess a state or a machine and then generate sequences to get to the final state. So it's not just a plain search problem like, for example, Google, or recommendation problem that you get Amazon to tell you buy these in addition to this. So it's not just a classification problem, this is a cup, that's a cell phone. It's not just classifying, it's actually also solving a problem. It's in addition to saying these things you would like to be able to generate or recommend sequence of actions. So I do a lot of research on the action part, and that probably comes from Herb Simon and Alan Newell.
Right, right. So I was going to ask you, because Simon said that we don't have to predict the future, we have to design it. So you're designing a very important part of the future, which is autonomous robots. So could you please explain a little bit the difference between an autonomous robot and some other types of robots, or what characteristics they have?
Yeah, so this is very interesting. So robots, it's very hard to define what's a robot, right? Because they have all sorts of shapes. But in some sense, and capabilities, but in some sense you kind of think that the robot is an artificial machine. So some kind of like, I have robots that are just a computer that have like a metallic column and wheels on the bottom. And that makes them a robot, because eventually it's a computer on wheels. And you can program these wheels to move, and our computers, our cell phones don't move by themselves, so they are not robots. So they have this ability to move. But then autonomous eventually means that these robots, or these artificial creatures, have a computer program on them that allow them to understand, perceive the state. They have a camera, and they can know, oh, there is an obstacle in front of me. Oh, I am at that distance from the wall. Oh, there is like this much temperature or this much noise at this point. So they can, through sensors, noise sensors, cameras, distance sensors, they can assess the state of the world where they are by themselves. And then they have this perception capability. And then they actually can use that to try to generate this sequence of actions I was mentioning, which we call the cognition part. So they are able to start to think about the problem they want to solve, all the ways that they can move, that they can actually take actions and generate a sequence of actions. And then finally, they actually can move. So robots, when we call autonomous robots, are machines, robots, that can do perception, cognition, and action in the same way that in some sense humans are called autonomous, because we can see, we can hear, we have our 5 senses, then we can think, and actually we can move. We can gesture, we can talk, we can actuate, we can pick up things, we can move them around. So we are a combination or an integration of these perception, cognition, and action, and that's in some sense that equivalent integration that we would like to have the robots exhibit to make them autonomous.
Great. Manuela, could you give us an example of something that is very easy for us humans to do and is very hard for a robot to do? Not necessarily, I'm not talking about mechanically, but maybe the computing side of it.
So, you know, definitely the perception part is very easy for humans. I mean, you and I look at this table and we have no question in identifying where the actual glass is. We have no problem in seeing that the glass has water. I mean, we have no, it's inconceivable to think that a human, unless it has some deficiency in its sensing, can understand the environment. So that's this type of like capability and enabling a robot or a machine to really process the scene and be able to extract all these features. I can count the books on this shelf if I want to. Having a computer that can do that is very hard. So the perception part is hard. But then what's very hard too, and it's easy in some sense for us humans, is this trying to solve problems that in a way that they are satisfiable. One thing that Herb Simon says, we are not always optimizing our decisions. I mean, up to the extreme. I mean, we are kind of able to solve problems. We have some level of heuristic thinking. We have some level of uncertainty thinking. We handle uncertainty well. I mean, we can understand, I was just asking, is tomorrow going to rain again? We have some prediction, we might dress ourselves differently, so we can solve the problem. I'm not here, I don't spend all my time thinking of what's going to happen and I don't move. So that's also hard for a machine to balance this issue about being able to optimize and search forever what's the best thing you should do, and try to find something that is not optimal but solves the problem within reasonable time. So from a scientific point of view, for us humans, we solve problems. We decide what should we have for dinner, and then we commit. Is that the best thing you could have? Probably not. I mean, how many of us eat the right food all the time if you would predict what impacts you 10 years from now, and all sorts of where does this food come from? I mean, if you were like optimizing all these decisions, but on the other hand, you still would like them to be of quality. So that balance between the quality and the optimal, to put that on a computer, it's difficult. And then finally, also in terms of actuation, you and I have no problem in moving in this floor, either whether it's carpet, you know, marble or whatever. And we can go up any stairs, and we can open any doors, and we don't have any problem picking up a particular book, picking up objects. That actuation part from the robotics point of view, my God, where are robots that actually can go up any stairs? Right. Where are the legs of these robots? And if they're on wheels, well, they cannot go upstairs. So from a mechanical point of view, I mean, we are amazing creatures, and let alone not talk about our hands, you know? So where are their robotic hands of the same level that we have? So in some sense, we take for granted all these aspects of the perception, of the thinking, even in regular situations, and of the actuation. And all of this is difficult for robots. It's not really the Einstein problem of being very smart about doing something. It's these regular capabilities, these just usual capabilities that we have a hard time both devising the actual artifact, what is it, metal, what is it, springs, what type of like structure has the same flexibility as our bones and our DNA. All of this is complicated. But on the other, so there are many limitations, but we make advances.
Great. So if I go and visit you at Carnegie Mellon, I was told that I would be escorted to your office by a robot. Is that true? What can it do?
Yeah, all the time. So any visitor that comes to Carnegie Mellon, I usually never say where my office is. I just say, Cobot, which is our robots, will meet you at the elevator. And these people say, what is this Cobot thing? And in fact, when they get out of the elevator, there is this Cobot, which is a robot which looks like a laptop, and then kind of like a column, like I was telling, and a circular base that has wheels, has on its screen, please let me know when you are ready. And the person says he's ready, and the Cobot says, I'll take you to Manuela's office, follow me. And keeps moving in these corridors, and you just follow. And the interesting thing about Cobot, just to finish this autonomy story, is that it cannot do many things. Like I told you, if it goes through a door and the door is closed, Cobot, that particular robot, doesn't have arms, doesn't have any manipulators, it just have wheels and microphones and so forth, but it doesn't have anything. So it needs to ask for help. So it's a robot that is capable of saying, can you please open the door for me? And if nobody opens the door, the robot is there. And it's stuck. It doesn't go further. But if someone generously says, oh, sure, opens the door, then the robot says, thank you, and goes. So this is what I call a symbiotic autonomy, in which these robots, these cobots, are able to ask for help for the things that they have limitations for. Even if you would say, oh, is there a cup of water on this table? Maybe the robot looks and has no algorithm to find out if there is a cup of water. And then it would give you this picture and say, is there a cup of water there? And the human said, yeah, and the robot gets it. So it's in this symbiosis, asking humans, asking the web, and actually asking other robots, and they are able to share this information, and this is what we call the symbiotic autonomy problem.
That's great, right? Collaboration between
humans and robots, but also from the initiative of the robot. Not only the human helping the robot and or being observing and following it. When the robot gets stuck, push it, or when the robot can't do this. No. The robot goes by itself and eventually requests itself, asks itself for help from the human. So because also for the humans, sometimes the humans don't know where the robot gets stuck. Why would the robot not know that there is a cup on this table? Unless the robot says, I have no clue. So it's these, you are right, it's a collaboration, but with initiative both from the human side and from the robot side.
Okay, so my next question is about the progress that robots and artificial intelligence are making, and these questions that people have about, will we lose our jobs, and what happens when the robots get into the services industry and take some of those jobs. So how do you see this process, and do you really think this is a problem, or actually this is good for the progress of society?
So it's hard to think about any technology that cannot have good and bad uses. Think about texting on a cell phone. It's great, but if you text while you are driving, you are going to have accidents. So if you use it not properly, a hair dryer, if you put it like in water while it's connected to the electricity, it's not a good idea. So it seems that we are surrounded by things that if we don't use them properly, that may not be as beneficial to us as they were planned for. So I don't think that the robots and artificial intelligence in general is outside of that. And therefore, it's true that as any technology, it's going to have good and bad uses. But my approach is that instead of thinking only about the possible dangers of artificial intelligence, which in fact it's more than a hair dryer or a text, or it's going to be, my robots are learning as they interact, so they become better, they become more knowledgeable, and they are really more present than just a hair dryer or a refrigerator, that's for sure. But instead of focusing on these dangers, I think that in some sense my approach has been that it would be a shame that humans are so smart and they cannot make good use of this technology. And the only thing we are afraid of is of the bad uses. I think it would be really a shame. So I really think that the way to perceive this is instead of making, I'm not saying we shouldn't think about that and shouldn't work, but instead of making follow that route, is to think that this AI and robotics is going in parallel with humanity. So why don't we invest on humanity and also on AI and these robotics to be of beneficial use? Imagine just an earthquake scene. Imagine a rescue situation. There are victims that need to be rescued. If there is a drone that is capable of surveilling everything and identifying where these people are is so beneficial, of such great use. Imagine environments where people like a shopping mall, where you would like eventually, if there is a robot, calls 911 before someone sees if someone falls down, if there is a problem. That would be so beneficial. Imagine if you really have like people that are handicapped and cannot, imagine just a blind person that is handicapped. It would be so good if that kind of wheelchair moves by itself. So there are so many things that we can use this AI and this technology for help of humanity, that I don't know. I just think that if we focus only on the bad uses, of course that's not a good idea. The job problem is a little bit also difficult to answer, because if you think about the telephone operators of the mid-century, right? They were like switching on a board. You want to talk with this person? Hold on a second. Ta-da-da, ta-da-da. They were switching. The moment we invented the digital switch, all of those people were out of jobs. And nobody said, okay, let's keep those jobs there and let's get rid of the electronic switches. There was really many people that got out of jobs. But what happened was that it's just a transition, because then the next generation, that's not even a job anymore. Because why would you think about being a telephone operator? You don't need that job anymore. So in some sense, I think that, again, I have a very big belief and trust on how the intelligence of humans. And it's up to us to make good use of this technology. And it's up to us to make sure that whatever jobs this technology is going to take over, we find one economy of talent, in which now what we do is about we are smarter, always have more ideas. I mean, we are going to be the Shakespeares, we are going to be the great design builders of bridges, we are going to be the great architects, we are going to be the great new computer programmers. I mean, the whole paradigm of being free. You know what? I don't mind if they invent a robot that cleans bathrooms. I mean, I don't need to do that. That's great. See what I'm saying? So if those types of jobs are going to be helped, that's fine. Just as a final thought, let me tell you one thing. I was reading this thing about when it was discovered that you could write instead of thinking. That was thought to be limiting to humans. Because now, instead of talking and having memory, you could write. That's cheating. You were supposed only to have memory. What is this thing about writing on paper? So that's a technology that was that was thought to be taking over a capability of humans, and that was not the case, right? It enabled us to go so far, just for the capability of writing. So my only call is that if people should listen to these dangers and these warnings. It's fine. Don't text while you are driving. That's fine. We should listen. But on the other hand, why not embrace and make great use of the computers we have, of the sensors we have, of the ability to actually have machines that enable you to help you think, making real recommendations, be support for humans. So it's a different paradigm to just look at this as an opportunity rather than a fear.
Great. So I know this is your first time in Argentina. You probably know that here, as also happens in your home country, Portugal, we're big fans of soccer.
That's right.
And one of the things that humans still do better than robots is to play soccer. But I also know that robot soccer is important in a way to show the progress of robots and of artificial intelligence. Why is robot soccer important?
So very good. So think about something. So I mean, talking about cobots, but you know that I co-founded RoboCup, which is this robot soccer competition, and I still participate, right? So actually last week we are RoboCup champions, and we keep playing robot soccer. Robot soccer has something unique, which is, first of all, the uncertainty of the opponent. So you have to address a situation that's very difficult from an algorithm point of view. You know, I have to write an algorithm that is capable of playing against any team, and you don't know what they're going to do. And so what I'm telling you is that robot soccer, not only challenges the teamwork problem, that it's not just one robot, but also the uncertainty. And then you think about fighting a fire in a forest. It's very similar to this problem of robot soccer, because there's fire that starts here, fire that starts there. You have to collaborate. You can never solve that complicated problem by itself. So that's why RoboCup also has RoboCup Rescue that builds on soccer. It's teamwork, it's uncertainty, and it's this ability to actually handle complex situations. And soccer is just, whether people like to or not, is an example of those type of challenges.
Great. So one of the things that the scientific community is working now is trying to understand the brain, right? How the brain works. So how important is for artificial intelligence to understand better how the brain works, the human brain works?
So unfortunately, I know very little about the brain, and I think that there are three directions in artificial intelligence. One is a very physiological, and it tries to understand how the brain functions to actually understand intelligence. The other one is really a very human-driven cognitive systems, in which you look at how humans do and try to have machines do the same. And then the third is more like the outcome. So what do humans perform? What can humans do? And that you would like a machine to do the same. We are all pursuing these three routes in parallel: the brain studying, the human studying, the just performance, the task. I don't know where we are going, but in the future, of course, if we would understand better the brain, it would be of great advantage for any artificial intelligent machine. It's just that we cannot wait to have the brain be well explained to try to make progress towards playing soccer or having service robots or having task automation. So here in the middle, we are worried about things that the robots can do: drive outside, take things out. So it's a very kind of like a more task-driven problem. But hopefully we'll benefit when the brain is more understood.
So my last question is about education, and I'm not talking about robots replacing teachers, but I know that kids love robots, and they're very good, to get some topics into the classroom. So can you talk a little bit about
Just 1 minute saying, it's fascinating how children get involved with robots, be it for education, be it for health. It's common. I have projects with autistic kids, and then it's very interesting. So we try to use that in some sense, or we try to follow that route to try to have children understand that they can be also actors in these technology aspects. So if you approach children with robots in which it's only like users of the actual robots, we don't get to the point of engaging them on the science of robotics. So the secret here is to use, in fact, robotics, but not as an entertainment, but as to try to get across to children that, in fact, the robot is something they can get engaged with from a development point of view, from a study point of view. It's like taking a kid to a hospital, not just so they can see, but for them to understand that they can become doctors and nurses, and they can be like the technical person that can look at like some X-ray. So it's like more like that robots have to play that role of being kind of enabling kids to understand about the science of math, the science of engineering, the science of psychology, that there are these cyber, physical, social systems that are eventually robots. So if the schools engage with robotics just from an entertainment point of view, it's not as productive as if you engage from showing that kind of like a career and kind of like problem and the fascination for what is this artifact all about.
Manuela, thank you very, very much.
Thank you. Thank you very much. Thank you for having me.